Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Real GMAT Problems, episode 21. Doing real GMAT problems can make test day way easier. So let's talk through a few examples together. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you can web search the questions if you'd like to follow along visually. Just so you know, the 11th edition of the official guide for GMAT review is out of print, and that's partly why I'm going through questions from that book, because that way if you purchase this year's official guide, there shouldn't be any overlap between the questions. The official guide contains retired problems that have appeared on past GMAT exams, so these are going to be very representative of the kinds of questions you'll see on test day. I'll give you a chance to work through the solution on your own if you want to, and then I'll discuss my thoughts on the problem and my recommendations for what to take away from each one. I recommend pausing after I read through each problem and trying to solve it, and try to visualize how you would solve it if you're on the go, meaning like if you're not able to write things down, just do your best to visualize as many steps that you would write down. And you probably won't be able to execute all of those in your head, but the exercise will really help when you are back at the desk, so to speak. If you're in a situation where you can physically write things down, I think that's ideal. So let's go. This is problem number 70. If x plus 5 is greater than 2 and x minus 3 is less than 7, the value of x must be between which of the following pairs of numbers? I'll read that again. If x plus 5 is greater than 2 and x minus 3 is less than 7, the value of x must be between which of the following pairs of numbers? Option A, -3 and 10. Option B, -3 and 4. Option C, 2 and 7. Option D, 3 and 4. Option E, 3 and 10. Again, just recommend pausing here if you want a moment to think through this. This should be a pretty straightforward problem if you understand algebra and inequalities. If you want some help reskilling with those topics, we've got math basics episodes on both of those linked below. So if you're just starting out or you're just not feeling the way that you want to feel on those, I'd recommend listening to those episodes first, because I'm going to gloss over some of the nitty gritty here and just talk a little bit more high level about this problem. I'm going to do my best to show you that if you just execute well on the basics of inequalities and algebra, you're probably going to get questions like this right pretty much every time. As you might suspect, though, we've got a fair number of folks picking some of the wrong answers. If you've been following this series for a while, I like to discuss that, and I like to talk about why that might be happening, because I think when you understand the pitfalls of these problems, you can construct an approach and you can instill good habits in yourself that are going to keep you from missing questions you know how to do. And I think missing questions that you know how to do is just one of the biggest and most painful score killers for people on the quant section. Just trying to help you get a head start on that, a leg up. Now, we've got a lot of people picking A, and we've also got a lot of people picking E. And so let's dive into how you can be sure that you're doing the right thing. First of all, just follow the golden rule of algebra here on each expression. And the golden rule of algebra is whatever I do to one side of the inequality, I do the same thing to the other side of the inequality. So similar to the golden rule in life, treat other people how you want to be treated. For the first inequality, x plus 5 is greater than 2. Let's subtract 5 from both sides to get x is larger than -3. And for x minus 3 is less than 7, let's add 3 to both sides to get x is less than 10. At that point, hopefully, you'd be able to recognize that x is going to be between -3 and 10, and you'd be able to pick A as an alpha, which is the correct answer to the problem. So this problem really is that simple. And that's why I was saying, like, if you don't have a good handle on the basics of algebra and inequalities, then like just go get that down, and this problem's probably going to be no big deal. But even though that problem is probably one of the fastest and simplest ones that we've discussed, period, in this whole series, why are so many people picking B? Let's really, really think about that for a second. B, as you might recall, is between -3 and 4 rather than between -3 and 10. So think about that. Well, if you think about the math we just did, why might someone be getting B? If you look at the second expression, which is x minus 3 is less than 7, and you subtracted 3 instead of adding 3 to both sides, then you would get that x should be between -3 and 4 instead of between -3 and 10. So like you might have done the first half right. On the first expression, you subtract 5 from both sides. That gets you x is greater than -3. But then in the second one, you just subtract 3 from both sides, like either just because of momentum or you missed a negative sign or you're trying to do it in your head and trying to quote unquote save time by not writing things down. Those kinds of things are all things that seem reasonable to do in the moment, but can just backfire. And I think this is one example of how that could backfire. All I do is subtract 3 instead of add 3, and all of a sudden I'm at option B. And if you think about it, it's interesting that B is one of the options there. Like, I don't know if it's a sinister thing on the part of the test writers that they're including that, or if they just looked at a big data set and they're like, why are so many people getting 4 here? Let's just make that one of the answers. Like, maybe it's super innocent, maybe it's something in the middle. Who knows? But the point is, you're going to see a decent amount of that on test day, where like tempting wrong answers or wrong answers that are 1 or 2 steps away from the right answer, they're probably going to be in the solution set. And that's just dangerous because it's a test where there's no partial credit. If you think about math tests you've taken in the past, even if you got the wrong answer, like if you got 7 out of 10 steps correct, or you got 9 out of 10 steps correct, and you just flubbed the math at the end, like you might have been getting an A on that exam. But on the GMAT, it's not like missing one question is going to make or break your score. But if you miss more than one question because of something like that, that definitely could make or break your score. So because there's no partial credit and it's an all or nothing situation, then these kinds of details just take on an outsized significance. And I think it can take people by surprise a little bit. So I just don't want that to be you. I want you to be ahead of the game with that kind of thing. So it's a pretty easy mistake to make, I think. But obviously, we want to minimize the odds of having that happen. So ask yourself, how could you prevent something like that? There are a lot of ways, but one of the easiest, I think, is just writing out all your algebra steps below each side of an equation or an inequality when you're doing algebra. Think about how you would write out your algebra if you were teaching someone how to do the problem. I think that's a really good metric for how clear you want your scratch work to be on test day. It's definitely a high bar, but I think if you really take a step back and ask yourself if the stakes here warrant your best effort, I think the answer will be yes. I think you'll just realize, like, I probably should just be writing that to the extent that it would be clear if I was teaching it to somebody, because the stakes are just so high. Like, I think you will arrive at that conclusion if you run the numbers on this. I might be wrong, but it's something to consider. At least run the numbers and ask yourself whether it's important enough to have clear scratch work. So what's interesting, I think, is that the second most common mistake is picking E as an echo. So any idea how someone might get that x should be between +3 and 10 rather than -3 and 10? Personally, I think that one's a bit more obvious. It's easy to simply drop or forget the negative sign there. Again, it's one of the best ways to prevent that kind of thing is just writing out your algebra steps. Just imagine this for a second. If under both sides of the inequality x plus 5 is greater than 2, you write -5. So you've got x plus 5 greater than 2, and then under x plus 5 you have -5, and then under 2 you have -5. You might make a mistake and write +3 below that, but I think the point is that it's extremely unlikely that you're going to look at 2 minus 5 on your page and then write positive 3. It's just way, way, way less likely to happen. And that's really our goal. It's I don't even know if it's a reasonable expectation to completely eliminate those mistakes, but we do want to reduce the probability that those mistakes will happen to the maximum realistic extent. So I don't know that it's about perfect execution, but I do think it is about the best possible execution that you're capable of. Again, just going back to like, do the stakes here warrant my best effort during the exam and during each question? Like, is each of the 21 questions in quant worthy of my best effort on the exam? That would be the probably a really productive frame to take there. So I think a problem like this is probably more about conditioning yourself to behave a certain way under time pressure than it is about mathematical knowledge. I could be wrong in your personal situation, but I think for the vast majority of us on this MBA path, like the math here is probably not going to be a huge hurdle, especially after you get those math basics down. But we've got a significant percentage of people picking answers like B and E. So even though obviously we need math knowledge to get this right, I really just don't think it's a knowledge problem. I think it's probably an execution issue. So hopefully that's helpful. Outside of those points, I don't think there's a ton more to discuss on that one. But if you do have thoughts or questions or feedback for us at any time, you can always reach us at the GMAT strategy on current social channels. And you can email us at contact, CONTACT, at thegmatstrategy.com. And we're always happy to hear from you folks. So reach out anytime. Let's try another question when you're ready. This is problem number 72. The problem says at least 2/3 of the 40 members of a committee must vote in favor of a resolution for it to pass. What is the greatest number of members who could vote against the resolution and still have it pass? Again, at least 2/3, so 2/3, of the 40 members of a committee must vote in favor of a resolution for it to pass. What is the greatest number of members who could vote against the resolution and still have it pass? Option A is 19. Option B is 17. Option C is 16. Option D is 14. And option E is 13. Again, recommend pausing and working this out on your own to the maximum extent you can. Diving into a solution, I think it's a great example of a problem that's a great follow-up to the previous one because mathematically, I think it's quite simple. But if you aren't careful or you don't have great habits, it's even easier to miss by the numbers than the previous one. So a full 15% of people are picking option D here as in delta, which is not correct. So keep in mind this isn't 15% of the general population who's picking D on this question. This is 15% of people who want to get an MBA. So it's already a pretty elevated group academically, and I guess not every business school even requires the GMAT. So maybe we're in like the top tier even of that graduate business school crowd, which is already a pretty small slice. You know, if you think about like a pie chart of all the humans on Earth, and you imagine all the people who have a great MBA, that slice of that pie chart might be like imperceptibly small, depending on how zoomed out we are. So it's already a pretty elite academic group, and then all of a sudden, 15 out of 100 people are picking D here. So as strange as it might sound, I think it's worth putting some emphasis on problems like this, even if your math skills are super solid. In terms of the math, we've got just a couple fraction computations to do here. It's not that intense. I think it's a little bit more computationally intensive than the previous problem, and maybe that's why we have more people picking D, but the wrong answers are so concentrated on D. I just think it's a good one to just kind of highlight for you here, especially if you're on the go. So if you're just starting out or you're not quite like on the level where you want to be with your fraction math, we'll link a math basics episodes on that topic for you below. But assuming you're okay with your fraction basics, let's talk about a correct solution. So starting at the beginning, it says at least 2/3 of the 40 members of the committee must vote in favor of a resolution for it to pass. So there are plenty of ways to do the calculation, and some of you may prefer to just estimate it. But if you're a little more like advanced in your studies, you've probably already got a way that you like to do this kind of thing. So I'm not going to push anything in that regard. But if you're not, and you're not already dead set on how you like to do 2/3 of 40, I'm going to make a potentially polarizing recommendation here. And I'm just going to suggest some long division. If you practice your long division even just a little bit, you can get pretty fast and accurate with it. And the reason that's a good idea is that it makes it way, way less likely you're going to miss questions that you know how to do. So there'll probably be way more complex and difficult questions on your official GMAT than this one. And we will get to those questions eventually in this series. But for now, what's probably the most helpful thing to know is that eventually, if you do a good job with your prep, you'll know all the material and you'll know how to do those complex kinds of questions. Like you'll have the knowledge, the content knowledge, and the strategic knowledge to be able to get from point A to point B and get questions right. But at that point, the biggest battle that I have seen people fight is not missing questions they know how to do under time pressure. That might sound like it's no big deal right now, and maybe you're one of those rare people for whom it's not going to ever be a big deal, and you're never going to like miss questions you know how to do, regardless of the effort you put in. That's amazing if that's you. But if you're like most of us, statistically speaking, it's just going to be a big challenge. And it's best if you develop good habits now while you're working on more basic questions, because it just doesn't get any easier to implement this kind of stuff when you've got way more complex problems and the clock's ticking down. And it's intense. It's really intense. So just doing my best to kind of help you get the direction that I wish someone had given me when I was starting out, or just early. Even midway through my process would have been amazing. So yeah, anyway, I hope it helps. But given that, what would long division look like here? Again, plenty of ways to execute. Here's what I would do. I would write 2 over 3 times 40, and then I would probably rewrite it as 2 over 3 times 40 over 1, just to keep myself from making mistakes and to make things easier to reason through visually. It's probably not a game changer on this problem, but I do think it's a good habit in general to take fractions times integer numbers and just turn the integer into a fraction over 1. It might be a small thing, but even if it decreases your chance of making a mistake on a problem by 1%, I mean, let's multiply 1% by the magnitude of the success here. Let's say on average it's about an extra 3 million over the course of your career. That's on the low side for a lot of you. For a lot of you going to top schools, it's going to be like 18, 19, 20 extra million, more than you would earn without the degree. 1% of that, it starts to add up. So what I'd do is I'd just perform the multiplication straight across the top and the bottom. Again, check out the Fractions Math Basics episode if you're not sure what I'm talking about there. And that would get me 80 over 3. At that point, it's not too tough for me to do some long division. If you want help relearning some long division, we've got a Math Basics episode on that linked below as well, along with one specifically about decimal long division, which I'm going to do in this situation. Now, I'm going to assume that you know how to do decimal long division here, and I'm just going to gloss over those steps because I walk through them in great detail in that Math Basics episode. And for those of you who are already comfortable with this, I don't want this series to get too long in the tooth. So what we would get if we perform long division of 80 by 3 is 26.66666 repeating forever. And let's think about what that means. 26.66 is the minimum number of votes that we would need to make a resolution pass. And if you think about that, then hopefully you can see that we would need at least 27 full votes. It's actually an important point to just quickly make. In all GMAT word problems, you can assume quantities of physical things are integers. So you're never going to have 3.7 stamps being traded in a barter situation. You're certainly never going to have 2.8 dogs at the dog park, and you're never going to have something like 4.8 adults in line and 6.2 children in line for the same movie. Like, that's just not going to happen. And if you're just getting started, I guess I should mention an integer means no decimals or fractions. We've got a Math Basics episode on that below as well. Just getting your basic definitions down. But basically, that's how we know that we're going to need at least 27 votes for the resolution to pass. If we need a minimum of 26.6 repeating votes, and the things that are voting are people, then we're going to need 27 people to get that minimum number of votes. So that's really helpful in answering our question, because if we need 27 at least, and there are 40 people, that means 13 could vote against the resolution and it could still pass. And that gets us our correct answer, option E as in echo. So why are all these people picking D here? I really don't think it's a math mistake. I really doubt that it's like, oh, 40 minus 27, 14. Like I think it's probably something else. But give it some thought. Why might someone get 14 here? I'm not 100% sure. I haven't watched 10,000 people do this specific problem, but I've watched a good number. And here's my guess. I bet that people think, okay, if I need two-thirds to vote for it, then I can have one-third of the people vote against it. So let me just take one-third of 40. That's my guess as to how the sort of like path toward the wrong answer of 14 happens. Now, if you think about that, that's actually a pretty clever solution, and it definitely seems efficient on the surface. But I think the risky part is doing the actual calculation. So if you do one-third of 40, you get 13.33333. And I think from there, it's just way too easy to apply the same logic that we use to round up 26.66 to 27 and just round up 13.33 to 14. I think there's just something about that that's appealing for the brain. Like it's got a gravity to it, if that makes sense. Because yeah, I've watched some super intelligent, super beast mode people pick 14 on this question, and it's just sometimes that happens. Sometimes that happens. So I mean, I think it's just really easy to say to yourself, oh, if 13.3 people can vote against it and it'll still pass, it must be the case that 14 whole people can vote against it and it'll still pass. Like, even though if you really think deeply about it, it should be the opposite thing. Yeah, I mean, it just tends to go that way. It's kind of interesting. So let's think a little more about that. The rounding should go the other way, just in case that's not super obvious. If 13.33 people can vote against the resolution and it can still pass, then if 14 people vote against it, it will not pass. And so 13 is actually the maximum. But for some reason, I think, yeah, I've probably said it a million times at this point, but just, yeah, let's just talk about how to keep that from happening. Sorry. I think the need to reverse that logic, it's just a little much in the moment when you've got the clock ticking down and you're just like, oh, cool, there's 14 right there. I think sometimes the mind just gets uncomfortable on these exams and it just kind of wants to get through the problems. And that's my guess as to why a lot of us end up picking D. So if that is indeed what's happening, what could we learn from something like that? I think there are a variety of possible takeaways. One could be like pause and think before selecting a final answer. That's one possible habit you could implement. Another could be double checking when you're rounding things up and down. That could work. A third thing might be to remember which way to round when you're maximizing or minimizing something. So in this problem, it's technically a maximum minimum problem. I can even think of some people preferring the takeaway to be always do the math on given quantities instead of doing the math on abstract quantities. So like the given quantity is 2/3 of 40. The abstracted quantity would be 1/3 of 40. So that the abstracted quantity, what I mean by that is it has to be derived based on the given information. It's not specifically given. Now, I think whatever your note to self ends up being here, or if any of those resonate at all, then I think that should be the one that you use. But I'll give you what I think is the most universal takeaway if you're not sure which one of those should be your takeaway, or if none of those resonate with you. And I think the thing that's the most universally helpful and the least universally harmful is just emphasizing words like greatest or least when you're transcribing the question in the first place. The first step for sure is always write what's given and asked. And I've given that tip just hopefully an unbelievable degree in this series. Like hopefully you're just super sick of hearing me say that, but you're getting great results on your practice sets and on your exams. But as an extension of that basic recommendation, you can highlight words like greatest or least by like writing them in all caps or underlining them or circling them or whatever works for you personally. And I think if you write what is the greatest in all caps number who can vote against, and then you reread that before selecting your answer, you're just going to be much less likely to pick 14, even though 40 over 3 equals 13.33333. Even though that math, 40 over 3 equals 13.333, is correct, if you're like, okay, what's the absolute maximum who could vote against it if 13.333 is the limit? Again, I think it just gives you that one little instant where you pause and you interrupt whatever that gravity is of the brain that naturally wants to lead us to 14. So it's really, really small things like that. It's definitely a small and subtle point. But I think that you will find out that as you scale your quant knowledge, that small and subtle kind of thing becomes super valuable because it compounds as you scale your knowledge to more and more problems and ultimately test it. Okay, so that's probably enough there. When you've got your note to self from that problem jotted down or sent to you for later as a reminder, let's try one more quick question together. This is problem 73. Problem says, in the Johnson's monthly budget, the dollar amounts allocated to household expenses, food, and miscellaneous items are in the ratio 5 to 2 to 1, respectively. If the total amount allocated to these three categories is $1,800, what is the amount allocated to food? Again, in the Johnson's monthly budget, the dollar amounts allocated to household expenses, food, and miscellaneous items are in the ratio 5 to 2 to 1, respectively. If the total amount allocated to these three categories is $1,800, what is the amount allocated to food? Option A, $900. Option B, $720. Option C, $675. Option D, $450. Option E, $225. Great problem to practice your ratio skills as well as your word problem skills. Most people are going to be familiar enough with the concept of a ratio to understand the basic math behind this kind of problem, and I think that's why a good number of people end up getting it right. So that's the good news. Having said that, enough people miss it that it might be worth installing a simple technique in order to make it a little bit easier as time goes on. In order to understand this technique, I think it's valuable to dive into the concept of a ratio just for a moment. Let's think about what it means to say that two quantities are in a ratio of 5 to 2. That means, perhaps obviously, that if there's 5 of thing A, there is going to be 2 of thing B. That's what a ratio of 5 to 2 means. But does that definitely mean that there's 5 of A and 2 of B? You probably know that it doesn't. Could there be 10 of thing A and 4 of thing B? Yes, there could. That's still a 5 to 2 ratio. How about 20 of thing A and 8 of thing B? Yes, still a 5 to 2 ratio. Again, most of us are going to be familiar enough with that concept to know that all of those are possible situations. But why can't there be 19 of thing A and 8 of thing B? Why can't we do that? Well, that's going to destroy the 5 to 2 relationship. So the key with ratios is to recognize that as long as you multiply each part of the ratio by the same number, you'll be retaining the original relationship. And we can express that with a variable. For example, instead of writing the ratio here as 5 colon 2 colon 1, we could write it as 5x colon 2x colon 1x, indicating that we can multiply that ratio by the same number, and as long as each part of the ratio is multiplied by the same number, we're not going to change the relative relationship between the quantities. That can be helpful because ultimately what you're going to want to do here is solve for the value of 2x. That's the dollar amount allocated to food, which is what we're being asked for here. So it's probably worth making a note of that early on in the problem if possible. So for example, I'd recommend not just writing what's the dollar amount allocated to food, but also writing like 2x equals blank or something like that. More on why I think that's a good idea in a second. Let's go ahead and solve first. Hopefully it makes sense that if we have $1,800 allocated to all the expenses, then all the expenses should add up to $1,800. Hopefully that makes sense. In order to solve, then all we have to do is add up the parts of our ratio. So I would do 5x plus 2x plus 1x. That gets me 8x. And if 8x represents the total amount of money that's allocated, then we can make an equation where 8x equals 1,800. So let's go ahead and solve. If you do your math correctly, another opportunity to use long division if you want, then you'd wind up with x equals 225. From there, we just need to double that to get 2x. 2x would equal 450, and that is our final answer, which is correct, and also option D, as in delta. So again, if you have questions about any of this stuff, just feel free to reach out anytime. I think if you're familiar with the 5x plus 2x plus 1x approach, this problem probably wasn't too bad. If you weren't familiar with it and this problem was a challenge, then I'd suggest adopting that technique for the future and maybe give a re-listen to the past few minutes if the way I explained it didn't like fully sink in the first time. That concept of a ratio scaling, if you multiply by the same number, if you multiply each part of the ratio by the same number. Many of these concepts can require repetition to really learn and understand. So please don't fear repeating things. It's something that I did to great effect when I was studying. Virtually all of my clients have intelligent repetition built into their programs. Yeah, I mean, if you need to re-listen to that, just like don't stress about that. It's really valuable. Quick note on my suggestion to write 2x early on in the problem. The most common wrong answer here is E, which is $225. I don't think it's a huge surprise. But the good news there is only 3% of people are going for that, which isn't too bad, I guess. And that suggests that as a group, future MBAs are actually solid with the ratio concept behind the problem, which I think is interesting. Because if you understand the problem well enough to get 225, that probably means you're not picking E because you didn't know the math, if that makes sense. Like you probably knew the math and you're probably picking E because you forgot what you were solving for, or you got confused about what you were solving for, which we're probably all going to do sometimes. But again, we just want to reduce that probability to the maximum realistic extent. And it's understandable to make those mistakes. I've made those mistakes way, way, way too many times. It's how I got into this space, helping other people avoid those mistakes, and part of the reason that I've kept doing it for as long as I have. Yeah, it's just really painful when that happens. But still, there's so much that we can do to keep you from making those mistakes and just accelerate your progress towards your goal and just make this whole process easier, which I do think is helpful. So if you were tempted by E, you might want to go a bit beyond my advice of simply writing what's asked. And you might want to take that extra step to then writing what's asked in mathematical terms. So it's a very similar recommendation that I made previously of like, if the problem has greater or greatest or least, like highlighting that. If the problem's asking you for a mathematical expression, but it's a word problem, you might end up writing what the problem's asked in words, which is a good step. I do recommend that. But you might want to take an additional step and say, oh, that's represented by 2x later in the problem. And then that can really keep you from picking something like E. Again, small adjustment, but I think you'll find it really valuable over time. Again, if you understand ratios well, if you have good execution habits, you're almost certainly getting this one right, like let's say 97 to 100% of the time. That's what we want. But let's pause and give you a moment to reflect, just in case there's something that you want to take away from that question and note to yourself. In fact, why don't we just zoom out from the whole lesson, 3 problems we just went through. Yes, on the easier side, but also on the remarkably easy side to miss, with particularly 15% of people missing that second one. Just ask yourself, what do you want to remember from everything we just worked through? One final time, feel free to reach out if you have questions. We're at the GMAT Strategy on current social channels, and we are contact@thegmatstrategy.com if you prefer email. We will be back soon with more advice to make this process as easy and painless as it can possibly be for you. As always, if you want more tips and strategies for optimizing your performance on the exam, please check out our website, thegmatstrategy.com, which is linked below. And I'd highly recommend scoping our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.